Question number 176. Select the mismatch. And the very first option given is charas and the match given is cannabis sativa. And this is a correct match because charas, which is a hallucinogen, is obtained from this plant known as cannabis sativa. So this is a correct match and cannot be a correct answer to our question. The next option is morphine and the match given is Papaver somniferum, and this is a correct match, so cannot be a correct answer to our question because this morphine, which is an opiate narcotic, is obtained from this plant Papaver somniferum. The next option given is atropine and the match given is Atropa belladonna, and this is a correct match, so cannot be a correct answer to our question. The next option given is crack and the match given is Dhatura. And as it is an incorrect match, so this is a correct answer to our question. Because crack, or also known as cocaine, is a stimulant obtained from a plant, Erythroxylum coca. So this is an incorrect match and it's a correct answer to our question. Let's discuss our next question. Question number 177. How many fragments will be generated in total upon digestion of a closed circular DNA molecule and linear DNA molecule with same restriction enzyme having 6 recognition sites on both DNA molecules? So let's draw first a closed DNA molecule and then a linear DNA molecule here. Suppose this is your linear DNA molecule. This is your circular DNA and this will be your linear DNA. Now the restriction enzyme will have 6 recognition sites on both DNA molecules. So let's suppose it will cut here 1, then here, second site, third site, fourth site, fifth, and then sixth. Third cut, fourth cut, fifth cut, and sixth cut. So it will form how many segments? It will form 1 segment, 2, 3, 4, 5, and 6. So in total, 6 fragments are formed from the circular DNA by this enzyme. Now let's cut the linear DNA. So there would be 1, 2, 3, 4, 5, and 6 cuts. And the DNA molecules formed would be 1, 2, 3, 4, 5, 6, and 7. So how many fragments will be formed on this linear DNA? That would be 7 fragments. So in total, how many fragments? 6 plus 7 equivalent to 13 segments. So the correct answer for this question is option number 1. That is 13 segments. Let's discuss the next question. Question number 178. The optimum temperature for extension step for Taq polymerase used in PCR is? Temperature of extension step for Taq polymerase. Now, out of the given options, the correct answer for this question is option number 2. Taq polymerase works optimally at 72 degrees centigrade for extension step. Now let's discuss other options also. The first option is 90 degrees centigrade and last option is 94 degrees centigrade. And 90 degree to 94 degrees centigrade is a temperature at which denaturation of DNA occurs in PCR. First step of PCR is denaturation of DNA and it occurs at 90 to 94 degrees centigrade. So this cannot be the correct answers. And the third option is 55 degrees centigrade. And we know that the temperature range from 50 degrees centigrade to 60 degrees centigrade is for the primer annealing. So this is an incorrect option. So the optimum temperature for extension step for Taq polymerase using PCR is 72 degrees centigrade. So the correct answer is option number 2. Let's discuss our next question. Question number 179. Which of the following is a crossbreed? The very first option given is mule. And this mule and hinny are the examples of interspecific hybridization. These are the hybrids which are formed by the crossing of horse and donkey. So these cannot be the correct options. The third option given is Hisardale, and this is the correct answer to our question, because Hisardale, it is a crossbreed of sheep developed in Punjab by crossing Bikaneri Eves with Merino Rams. And this is the correct answer to our question. The last option given is Jersey, and Jersey is an exotic breed of cattle. So this cannot be a correct answer to our question. So the correct answer is option number 3. Let's discuss our next question. Question number 180. Restriction enzymes are part of host control restriction system. They protect bacterial cells from bacteriophage infection by. And we know that these restriction enzymes, which are a part of control restriction system, they will restrict the growth of virus inside bacterium. They will not prevent the entry of these viruses or bacteriophages into the cell, but they will inhibit the growth of these viruses inside the cell by digesting the viral DNA. This bacterial DNA is protected from the action of this restriction system, as the bacterial DNA is modified by the action of DNA methylase, so that bacterial DNA is no more recognized by this restriction system. This system will now only act on the viral DNA and not on the host bacterial DNA. Now let's discuss the options. The very first option given is preventing the entry of virus in bacterial cell, and this is an incorrect option because this restriction system will not prevent the entry of bacteriophage into the bacterium cell, but it will inhibit the proliferation of this virus inside the bacterium. The next option given is digesting the viral DNA, and this is a correct option and is a correct answer to our question. The third option given is promote the replication of viral DNA, and this is an incorrect option. It will inhibit the replication of viral DNA by digesting its genome. The next option given is preventing the assembly of bacteriophage inside bacterial cell, and this is an incorrect option because this restriction system will digest the DNA of the virus. So the correct answer for this question is option number 2. So with this question, I would like to end up the discussion of this AIATS paper. I hope all your doubts and queries have been solved regarding this paper. Thank you very much for watching and all the best.